Welcome to the demonstration of Bio-Rad's Risk Calculator. Go to missioncontrol.qcnet.com. Bookmark this page so that it is convenient for future access. Enter your username and password. Click Risk Calculator. From the Testing Methods page, select the instrument and analyte you want to work with. In this case, we will select the VISTA as our instrument and protein as our test. Click Next. From the Single Analyte Report page, enter the input parameters. Since you are already a Unity real-time user, most of the required inputs have been directly downloaded when your lab was set up. You still need to enter the NB, which is the number of patient samples between QC runs, and the ND, which is the number of patients run per day. In this case, the input is 200 for both. Click Calculate Results. The results of the risk calculator are shown in the form of an infographic. The green represents good QC events, and the red represents a bad QC event. The yellow triangle represents a point where an error event has occurred. In this case, the instrument failed to detect the error at the next QC event, which is green. And in fact, it would take multiple QC events before the instrument would detect this error at the red test tube. What this means is that patient results that are reported after the error could be affected by the error. The risk calculator provides this number for you. It is referred to as the expected number of unreliable or incorrect patient results that are final, or enough for short. These values are shown in the first orange row below the infographic. Ideally, we want the error represented by the yellow triangle to be detected by the next QC. So the best place for the yellow triangle to occur is between the last good green QC and the next QC, which is red, indicating it detected the error. The lab would likely not report the patient's results if the QC was out until the reason for the error has been investigated. In theory, this would mean that the enough would be 0 because the error was detected by the next QC event and incorrect results are not reported. In our example, the expected number of unreliable or incorrect results that are final is almost 27. The first question to ask is, will your lab be okay with the possibility of reporting 27 incorrect patient results? Probably not. So let's explore if it is possible to improve the enough and the expected number of QC events to detect the error, or EQCE. A first step to consider is to determine if the coefficient of variation, or CV, is too high and whether it can be controlled. If we look at level 1, the CV is 7.64. This is rather high and may be a culprit. Let's say the standard deviation, which is 0.32, is incorrect and really should be 0.032. When a new calculation is run, the yellow triangle error is detected by the next QC, and the enough is now less than 1. Mission accomplished. However, if the CV is correct, then we will need to look elsewhere. Sometimes the sigma metric will be too high or too low. The sigma metric is directly related to the allowable total error. When the TEA is increased, the sigma metric will also increase. And when the TEA or sigma is increased, the enough will be reduced. The recommended ideal range for sigma is between 3 and 6. In our case, the sigma is 3.2, which could be a candidate to be increased. However, since the TEA is already set at the CLIA minimum of 10% for protein, it is not recommended to increase the TEA. Let's now consider an adjustment to the QC rules. Consider that the QC rule is 1,3S. It might be possible to improve the risk performance by trying a rule that makes it easier to detect the error, or a more powerful rule. Let's try a 1-2s rule. This will reduce the enough from 26.8 to 2.7, but notice that the false rejection rate, or FRR, has increased from 0.5 to 8.9. This false rejection rate likely will not be desirable because then you will have to address too many false alarms. Instead, let's try a repeat 1-2s rule, which reduces the enough from 26.8 to 14.6 and only increases the false rejection rate to 1%. Another consideration is to run a third level on QC. If the third level has a mean of 11.0 and a SD of 0.12, and the rule is changed to a multi-rule of 1-3s and 2 of 3-2s, we get an enough of 2.7, an EQCE of 22.6, and a FRR of 1.1. An additional benefit is that the sigma metric has increased from 3.2 to 6.8. This is much better performance. We have controlled the risk of reporting incorrect patient results and increased our sigma, and all we did was run a third level on control. As a final step to further reduce enough, consider changing the frequency from every 200 patients to every 100 patients. When NB is set to 100, the enough is reduced to 1.3. Excellent all-around performance. After completing this process for all analytes on the instrument, it is possible to print a summary risk assessment report. This report will help you quickly determine which analytes need attention, those that have the yellow triangles toward the left side, and which analytes are performing well, those that have the yellow triangle toward the right. We hope you've enjoyed this risk calculator demo. Please visit us at missioncontrol.qcnet.com for more information.